quick look at, shall we say, capturing behaviour of closures. So here's a program that has this method here called generate accumulator function, and that just takes a single parameter, which is going to be a running sum, and this is the initial value of it. Now, what is interesting about this is that it returns not a value as such, but a function. This is a function that takes an integer parameter and returns an integer. So this is going to return back another function. And you might think, well, why would I do that? Okay, let's actually step through this code and see what it does. So we're here, and the first thing we're doing is we are calling generate acfunc and passing in the value 10. So we step in, we set the accumulator ACC to the initial value 10. Okay, so this is a local variable inside the generate act function, which would normally be destroyed when we exit. However, we're going to return a closure. This is a closure that takes an integer parameter and returns an integer parameter. And notice that it makes reference to this local variable ACC. Now, because I've made reference to it, it is said to capture it, this specific instance of it. So that means logically relocating it somewhere out of the stack space where it can persist. Okay, so we step out of there. Now we go to the next line. Before we step into that one, let's just check this. If we hover over acfunc1, we notice it's a function type, system.func int, takes an integer, returns an integer. So what we've got back is not a value, but just another function. But that function has also captured ACC with its initial value of 10. Now when we go into the next one, this time ACC is a different local variable to the previous one with an initial value of 1. And again, we're going to return a function that captures ACC. Now that is distinct and different from the previous one. Okay, so now we've got two new functions, acfunc1 and acfunc2, and we can call them as ordinary functions. And notice we pass in an integer, but we're not bothering with the return value. So I'm going to pass in 2. So if I step into that, you'll see that there's the code, right? And we're on this one, ac is 10, if you recall. I'm going to add u to it, which was a 2. So now ac is 12. Now we'll do the second one. It's a same code, different captured data. So if I step into this one, again it's the same program code, but notice that this time the captured accumulator value is a 1. That's what we set it up with. Add on our value of -5, gives -4. Okay, and we return it for convenience. Okay, I'm going to do that again now. So we're going to call acfunc1, passing in a 3. So the accumulator is currently 12. Add 3 to it, makes 15, and we return the value and store it in y1. Similar thing for y2, and then when we print them out, we see the two values. So what is quite interesting about this is that not only do we get back a function, but we get back captured data as well. Okay, so as I said before, it captures it from its enclosing scope, which is this outer function here. Okay, so ACC is made reference to in here, so it's captured and recalled. And we initialize that typically through a parameter. And this is a common trick used in things like functional programming, which this course is not about, but it's interesting to see.